Delaware Tech, Chemistry 100, Chemistry 110, salts. Salts are just ionic compounds. And we've already learned that salts can be produced from acids and bases mixing together. So whenever you look at a salt, one way to determine whether that salt has properties in terms of being an acid or base itself is to look at the component ions of the salt. And what you're going to do is you take your salt, if you want to determine how it behaves, you add an OH to the cation of your salt to get the original hydroxide base that it could have been produced from, and you add a proton, an H+, to your anion portion of your salt to get the acid that it may have been produced from. Okay, well, what does that look like? Well, if we start with sodium chloride, Na, which is Na+, and Cl, Cl-, and we split the ions apart, and we add an OH- to our positively charged sodium ion, and we add a proton to our negatively charged chloride ion, we would generate sodium hydroxide and hydrochloric acid. Now, we can't do this typically. This is a very difficult thing to do in this direction. This is a theoretical idea of trying to figure out what acid and base would have produced sodium chloride. Well, it would have been HCl acid, hydrochloric acid, and NaOH, sodium hydroxide base. They would produce our salt. And the reason why this is important is that salts can be acidic in some cases, they can be neutral in other cases, or they can be basic. In other words, putting just certain salts in water without any other added acids or bases can make the water acidic or basic or not have any effect on the pH of the water. So how do we tell which one's which? Well, we have to look at the parent acids and parent bases they were made from. So sodium bromide, NaBr, would have been made from sodium hydroxide, a strong base, and hydrogen bromide, a weak acid. And because this was made from a strong base and a weak acid, the salt itself would be considered a basic salt. So if you see a strong base and there's nothing to balance it, the salt will be a basic salt. Potassium carbonate, K2CO3, that would have been generated from KOH, and the CO3 turns into carbonic acid, H2CO3. KOH is another strong base. Carbonic acid is a weak acid, so the strong base wins out, and therefore potassium carbonate, K2CO3, is considered a basic salt. We also have examples where the component ions turn into both strong bases and strong acids and cancel each other out. Sodium chloride is an example of that. It would be from sodium hydroxide, a strong base, and hydrogen chloride, which is really hydrochloric acid, a strong acid. And if they're both generated from a strong acid and a strong base, the salt is neutral. They've canceled each other out. So magnesium sulfate, the same thing, is from magnesium hydroxide, a strong base, and sulfuric acid, a strong acid. So we have a neutral salt. Calcium nitrate from calcium hydroxide, and the nitrate becomes nitric acid. Both of these are strong, again, a neutral salt. And we can have the opposite situation, as we saw in the beginning of these, ammonium sulfate. Ammonium is our cation. So if we add hydroxide to ammonium, we have ammonium hydroxide. Remember, ammonium hydroxide is just the same thing as ammonia in water, and this is a weak base. But sulfate becomes sulfuric acid, and that is a strong acid. So strong acid has the higher effect here, and therefore this is considered an acidic salt. So the idea here is that you're looking for the balance of the two. If they came from a strong base and not a strong acid, it's going to be a basic salt. If they came from a strong acid and a strong base, then they cancel and it's a neutral salt. It doesn't change the pH when you put it in water. And if it came from a weak base and a strong acid, the acid will win out and the salt will be acidic, meaning when you put the salt by itself in water, the pH will go down. It will appear acidic. Note that in these cases, please be aware that these are not, you're not making these acids and bases from the salt. The acids and bases are being used to make the salts, or at least you're thinking about them in that term. So you're just looking theoretically what acids and bases they come from. You'll notice the one category I didn't cover is a salt that's made from a weak acid and a weak base. And in those cases, you have to look to see how weak they are and how much they compare to one another to really decide is the weaker base is the base weaker as a base than the acid is weak as an acid, and that requires calculations that are beyond the scope of this course.